Okay, today we're going to talk about properties and not like a monopoly, but properties of mathematics. And I've entitled these notes Property Fun, obviously, super fun. Maybe I should rename this super property super fun. But there's several properties that you spend a lot of time, maybe in the earlier grades, and even reiterated last year. And we'll get to those. Two properties that maybe you've talked about, but we're going to spend a little bit more time this year. Is inverse property and identity property. Inverse and identity properties work for addition and multiplication, a lot like two other properties that you know, right? Associative and commutative work for addition and multiplication. And the inverse property, right, of addition says any number plus its opposite is equal to 0. So again, for addition, inverse in addition is a number and its opposite. For example, 3 and negative 3. Right? If you had 3 and negative 3, that would equal 0. If we're talking about multiplication, right, now the inverse is the reciprocal. So in multiplication, inverse is reciprocal, and when we multiply a number and its reciprocal, or a number and its multiplicative inverse, our result's going to be 1. Other property, very similar, they're kind of related, is that the identity property of addition says that any number plus 0 is equal to itself, and in identity, any number times 1 is equal to itself. So 0 is a main feature in both inverse properties for addition. Alright, the first one is any number and its opposite is equal to 0, and identity is any number plus 0 is equal to itself. And then for multiplication, the main feature that's in both of these is 1. Right, times 1 to equal itself for the identity, or any number times its reciprocal or inverse is equal to 1. Two properties that I'm sure you're very well aware of. Commutative property, right? We know what that does. It says that you can change the order of addends or factors. So I want you to think about, what does that mean? Addends or factors, without getting a different sum or product. So that's a clue, without coming out and saying it. The commutative property works for what two operations? Addition and multiplication, of course. Right? Same two that we talked about for identity and inverse. Associative property, you can change the grouping, how the factors, the addends are grouped together, or the factors are grouped together, and you'll still get the same sum or product. Right? So we know that if we get 3 times 4 times 5, right, that's 12. Yeah, but go over there 1. There we go. 12 times 5, which is 60. If we change the order, 5 times 3 times 4, right, 15 times 4, we know is also 60. Okay, so you get the same product even if you changed it, and we know that. All right, we've been to 4th grade. Thanks a lot. All right, so I want you to think about this question. What's the main difference between these two expressions below? All right, what property would I use for each? Now, hopefully you said to yourself, self? Well, hopefully not talking to yourself. But in the green, right, there's no addition within the parentheses, okay? So this is indicating that we've got 4 times 12 times x, all multiplication. Whereas in black over here, we've got 4 times the sum, 12 plus x. Alright? So, can you use the distributive property for both of these?
May I have your attention, please?
And so, the distributive property can only be used on the one on the right. Right? If I take a look in red here, I've changed the green expression and regroup the 4 times 12 because they were all multiplications. So now I'm going to group together the 4 times 12. Notice I haven't changed the order. So 4 times 12, which becomes 48x. Right? But on the right in black, because it has two terms, two separate terms inside the parentheses that I'm not allowed to add together because they're not like terms, I need to use the distributive property for that. So in red, alright, I'm using the associative property to regroup the factors 4 times 12 to make 48 times x or 48x. And in black here, I would be distributing the 4 into both of these terms to get 48 plus 4x. I guess the other point that I wanted to make here was if I can I move this down? That's better. If I have this 3 times 4 2 1 2 x y to the third z to the eighth, there's really only one term in this parentheses. Terms are separated by pluses or minuses, so I wouldn't distribute here either. This would just be multiplying, regrouping really the 3 times the 4212 to make whatever that is. It's a huge number, and it would still just be one term. So distributive property, when we use that one, it's multiplication over addition or subtraction, and we got to have two unlike terms in order to we'll multiply into unlike terms. All right, and a term is, and you should write this down. Right, term is any number, variable, or a product of numbers and variables. Okay, term is any number or variable or product of numbers and variables. 3 plus 2x is two unlike terms because one is a constant or a plain number, and one is a algebraic expression 2x. Right? Well, that algebraic term, we should say. 3 plus 8. Yes, I was in first grade at one point, Mr. Bossert, and that's 11. And I can add those because they're both constant or like terms. They have to have the same variables and exponents to be like terms in order for us to add or subtract. But we can multiply anything, and that's going to be key for us here. Now the distributive property of multiplication or addition says that, again, any number times the sum or difference is the same as that number times each part. So we know that 3 times 8 plus 12, right? In red, I have over here, that's 3 times 20 by the order of operations, which is 60. And we know that it's the same, that if I multiply 3 times both parts, I get 3 times 8, or 24, plus 3 times 12, which is 36, and together that's 60. So we get the same one. Now obviously for this one, we would not be using the distributive property. We would be doing what's over here in red. We would be adding together, because we can add the like terms in there and get 3 times 20. But you could do it the other way. Now, the distributive property is awesome for doing mental math. So instead of 15 times 63, doing that in your head might be difficult. But if in your head you break it up, right, and you do 15 times the 63, break it up into 60 plus 3. Now in your head, 15 times 60, alright, hopefully you may or may not know that it's going to be 900. 900 plus 15 times 3 is 45. So that's going to be 945 without having to write anything down. Alright. When you actually multiply long ways, like you learned how to do in 3rd grade, what you're really doing is you're taking this 312 up here, this top one, and you're multiplying it by 1. Right? You're multiplying it by 1. Right? And then you're multiplying it by 10. Right? This 1 is not really a 1, it's in the tens place, so it's a 10. And then you're adding them together. So it's the same as if you want to split them up. Right? When I do it mentally, instead of 1 plus 312 times 1 and 312 times 10, I usually do the 10 first. So 312 times 10, in my head I can tell you that that's 3120, and then 312 times 1, I got to add 312. So in my head, can you do this, right, to get 3432, if I get it all right. So how about this one? Can you break this one up? All right, anybody done? I'm done. So I'm going to multiply this, and I'm going to break. How about I not erase? How about I draw? Okay, that's good, Bossard. So I'm going to do this. All right, 12 times 2 and 12 times 0.05. 12 times 2 is 24. 12 times 0.05 is going to be 0.60. Right, because 12 times 5 is 60, and there's 2 decimal places. So this is 24.60, or 6. Right, pretty cool. And again, I could break it up any way I wanted to, but I would choose to do that. This one, you could either break it to 21 times 100 and 21 times 8, or maybe you do 108 times 20 and 108 times 1. That's up to you. So again, one option would be in your head, break it up into 21 times 100, and then 21 times 8, which would be 2100, and then 168. So 2168. Not sure why it's doing that. I apologize. The other one would be maybe do 108 and then multiply it by 20 plus 1. I don't know if that one's any easier. This would be 108 times 20 would be 2160, and then, or 2060, and then 108. $2,100 would be 2268, wouldn't it? Yeah. Alright, I gotta fix my pen. Anyway, 2268. And that's going to be the end of this section. So thank you very much. Again, we're talking about properties, commutative, associative, inverse, identity, and distributive. Hopefully you have a good understanding of all those at this point.